This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. So in this video we're going to be looking at area of a sector and length of an arc. So the formulae for length of an arc and area of a sector can be found in your tables book, and they're shown below here. Length of an arc is equal to 2 pi r multiplied by your angle theta, which is here, divided by 360 degrees. Now those of you studying higher level will have met a different formula when you're working in radians. The length of an arc is equal to r times theta, where your theta there is in radians. And the formula for area of a sector is equal to pi times r squared, again multiplied by your angle theta in degrees over 360 degrees. And once again, at higher level, when you're working in radians, this is equal to 1/2 r squared theta, where this theta again is measured in radians. Now we're just going to go through an example here of using these formula in practice. I'm going to be using the ordinary level formulae. So for higher level, you just have to convert your angle into radians and then use your radians formula that was on the previous slide. So our first question is to find the area of a sector of a circle of radius 4 centimeters if the arc of the sector subtends an angle of 60 degrees at the center. So what does this sentence mean? So we're given two really important bits of information here: our radius, which is 4 centimeters, and we're told we have an angle of 60 degrees at the center. So the first thing we're going to do is just draw what that looks like. So we'll have an angle of 60 degrees, an arc, and each of these sides is going to be our radius of 4 centimeters, and our angle of 60 degrees. So we have r is 4, theta for our formula is 60 degrees, and we're asked to find the area of the sector. So our formula then for area is pi r squared multiplied by theta divided by 360 degrees. Which is equal to pi times 4 squared, all multiplied by 60 degrees divided by 360 degrees. Simplifying this a little bit, that means we have pi times 16 times 1 over 6. And putting this into our calculator, we get that A is equal to 8 over 3 pi centimeters squared. Just leaving it in the most general form. And the second part of this example reads that the radius of a circle is 10 centimeters. Find the angle subtended at the center by an arc of length 4 pi centimeters. So a slightly different question, but first things first, we'll have a look at what information we've been given. So we're told the radius is 10 centimeters. We have an arc of length 4 pi centimeters, and we're asked to find the angle subtended at the center. So once again, we'll just draw ourselves a little picture. So we have our radius of 10 centimeters. We have an arc length of 4 pi centimeters. And our unknown in this case is our angle theta. So this is what we're looking for. So the information we're given then, r is 10, L is 4 pi, and we want theta in this case. So if we look at our formula for length, L equals 2 pi r multiplied by theta over 360 degrees. If we fill in our information, on the left we have 4 pi. Filling in our radius, we have 2 pi times 10. And we leave this as it is because we don't know theta. Simplifying the right-hand side a little bit, we have 4 pi is equal to, I'm just going to rearrange to put theta in front, same multiplications happening, times 20 pi. That's just simplifying this part here. So now we want to get theta on its own, so we're going to have to multiply both sides by 360 degrees first. So now our 360 degrees cancels on the right hand side, and we're left with 1440 pi on the left is equal to theta times 20 pi on the right. So if we divide both sides by pi, we can get rid of our pi, making our calculation a little easier. So we have our theta is going to be 1440 divided by 20, which is equal to 72 degrees. And that's our answer for theta.